As you can see early on in this presentation, I'm trying to come at moderation from multiple angles so that you understand it both statistically and conceptually in a deeper way. And so in this case, I want you to look at it as a visual presentation. So understanding it in this way, where we have remember our scatter plot. I think that's just the easiest way sometimes to think about relationships among variables, and we have these points scattered around the best fitting line. Recall in simple regression we have that very easy to understand best fitting line of predicted values of y. And remember, in simple regression, we have just one predictor, one outcome, so it's in a two-dimensional space. When we make that scatter plot, we have the x-axis and the y-axis, and it's flat. In multiple regression, it's a little bit different. When we have two predictors, each predictor gets its own dimension. So we have predictor 1 is a first dimension, predictor 2 second dimension, and then the dv is the y-axis, of course, and we have a three-dimensional space, which is kind of cool, and that is illustrated in the picture on the left. And specifically when no moderation is present. So we have these two predictors, and this is an example from field again, where we're trying to predict record sales of bands from the airplay on the radio and their advertising budget. So we have again two predictors, one dv, and we have these points scattered in three-dimensional space, as you can see. And the best fitting line goes from a best fitting two-dimensional literal line to a best fitting plane of predicted dv values. And so that plane kind of rotates there in the three-dimensional space around those points that are suspended in the space, and that is what we have for two predictors. Now please note that if we have more than two predictors, then we have no way to visualize this anymore, because it becomes a 4, 5, and 6-dimensional space, which we can't even imagine really. So the only way this works is with two predictors. But just for learning purposes, I think it's interesting to illustrate it this way. Finally, for the interaction, when we have a moderation present, as you can see on the figure to the right, that's more colorful. It has the reds and the yellows, etc. This plane actually twists and contorts. So when there's no interaction present, the best fitting plane of predicted y values stays flat. But in the interaction, what happens is that relationship is going to change across different values of the moderator, so it's going to contort and look twisted as it does in the illustration to the right. So this is just another way to think about an interaction, to visualize it, and hopefully by now you're thinking of different examples in your field where you're seeing a moderation or thinking that it's happening in the population.